Thank you.
Mm-hmm.
It's E.T. and evil E.T.
Oh no!
Oh my gosh, well that sounded evil.
Let's see.
All right, here we go. All right, quick review. Yesterday when we did this question with composite figure, let me move this over here. We had to get the area of the entire thing, which was 100. Then we had to get the circle diameter, which is 10. Half of that's 5. 5 times 5 is 25 times 3.14, and then subtract the 2. And we got 21.5, I believe. All right. So moving on. So on your screen, will you show me an example of how you would so make a composite figure and show me how you'd get the formula. Draw a composite figure of your own and then show how the formula of it would be done. So on your screen, and if you're just joining, the screen code is see it on my screen. LIKTP. LIKTP for Pear Deck. So again, you're just drawing a little, you can't see mine. You're drawing a composite figure of your own and showing how you would get the area of that composite figure, please. So I've got a square that has a triangle attached. That's being divided into 2 pieces to get the response. I have a big giant L. Good job there, Angelo. You divided it into 2 little triangles. I've got a baseball diamond going on. Got what looks like an ice cream cone, sort of. I've got what looks like a house with a triangle and a box or a square. Good. All right. So it's all about looking at the bigger picture and taking away subdividing the actual separate shapes in the composite and getting the separate areas and adding them together. All right. So now we're going to talk about rectangular prisms. On your screen right here. Okay, on your screen you have a rectangular prism. It shows you the answer. Will you, on your Pear Deck response, tell me 2 things? 1, how did they get that answer, and what's wrong about the way they wrote their answer? So 2 things if you'll respond. How did they get that answer, and what is incorrect about the way they gave the answer, their response? What's incorrect about it? Let's see what you're saying. Hey, Miss Parks.
Hey, guys. Hi, Mr. Parsons.
Yeah, we're doing.
Hello. Hey, Miss Park.
Hi. I will mute my, oh, hello. There's Betty. All right. I'm swiping to see. Mr. P, where are you?
I
Hey,
should,
Mrs. Burks.
Hi, who said that?
Izzy.
Me, Graham.
Oh, Graham.
Famous
Hey,
parts.
Graham, I walked by your house this morning and waved twice.
Oh, we must have missed it. Oh, sorry. Wait.
Next time I'll throw a rock.
Sounds good.
Or the window.
Yeah. Aim for the window. That'll get our attention
I
quickly.
will. I'm going to. Yeah, big one.
Famous parts.
Hi, who is that?
Is he?
Hi.
Hello.
Hello. And who's
I need to
kid?
help you. You're not doing very well.
How have you been?
Okay, I'm just going to watch. I'm going to mute myself and watch.
Okay. Good to have
My P deck isn't working.
The Pear Deck is LIKTP.
Yeah, the code it's not actually it's just loading.
Okay, let it load. All right, so a lot of you are saying that what they did was they went length times width times height. Great. Could someone, some of you also said, yeah, but the length and the width is really the area of the base, which we use a big B to talk about when you're talking about the base of a solid versus the base in a two-dimensional polygon. Would somebody elaborate on why that's a safer way to do? Would elaborate on why getting the area of the base of the solid.
Can you repeat the question?
Yeah. The question is, why would get? Hang on.
Who did this?
We don't hear.
Who did that? What happened? This is dumb. What did you find? So I did
So, why is it safer? If you have background noise, if
Betty,
you-
did you do this yesterday? Yes, because we didn't hear us.
Okay, I'm going to mute everybody for just a moment because there's background noise going on. So if you're ready, when you need to talk yourself. All right, the question is, why is it safer to talk about when you're doing area of prism, volume of prisms, that you get the area of the base times its height instead of just using this length times width times height? Why is that a safer way to talk about this? For learning. James, you talked about it. You want to share what you said?
I thought that they should have put the length times width as base of put length times width, because length times width won't always get your answer. Like if you have a cylinder, if you do length times width, you'll get the volume of a rectangular prism.
Okay, so that's correct. This formula, length times width times height, only works on one thing, and that's a rectangular prism. It's about getting the area of the base. So it's about getting this part here. Uh-oh, hang on just a second. So it's about me getting this part here. And then from that, seeing, well, how tall is it? I'm going to use this tallness back here. All right. So in this particular case, the area of the base of that would be 15. And it's 15 times 4 tall. And if you remember yesterday, in case you weren't here, it's literally like I'm saying, okay, here's layer 1 of cubes. Here's another layer of cubes, right? A third layer of cubes and a fourth layer of cubes, all right? So that's the safer way to think about this. Layer 1, layer 2, layer 3, and layer 4. And every layer had 15 cubes because I know 15 because it was length and width of 5 and 3, all right? And then on your text, you also said, let me get Jayla in here, mouse admits. I also asked you to tell me what is incorrect about the way the graphic showed the answer. Could someone tell me what was wrong in the way they answered it? 60 is the right number. Inches is the right linear measure, but what is missing? Josie, what's missing?
They didn't say, they didn't put in the cubic part. They only said 60 inches. They didn't say.
So that's right. We need right here for there to be a cubic inches, right? So we need to say inches cubed with the power to 3 or the word cubic, because it's literally about how many cubes are in this. So if you think about it like this, it's like, here's a cube, here's a cube, here's a cube, right? And then there are 3 back. Okay, 1, 2, 3, 4, 5, and then they go back 3. So there's 15, 15, 15, 15, right? All right, anybody have a question about that? All right, I'm gonna clear it. And let's move to the next one. Will you please try, no, we did this one yesterday, so I'm gonna clear the drawings. Could someone recap this one from yesterday? Who would be willing to recap? Betty, raise your hand.
So I think you have to do like 3 times, like just do like, can you repeat the question?
Yeah, can you recap how we do this one?
Okay, so what you have to do, don't you have to do like 3 times 3 times 3?
Okay, so let me ask you this, Betty. What is the bottom layer of this solid made up of? How many cubes are on the bottom layer?
3.
3 in the front, and there's how many rows of those 3 on the bottom?
2.
2. So how many total cubes are on the bottom layer?
6.
6, okay? So there's 6 here, right? So we got 6 cubes there. How many are on the next layer here, Betty?
6.
Also 6. How many are on the next layer, Betty?
6.
6, all right? So there are literally 6 cubes on all 3 layers, so it's a total of 18 cubic units, correct?
So yes. So would it be written like in parentheses 3 times 2 and then out of the parentheses times 3?
So it would be written like this, okay? Volume is the layer of the base times the height. All right, so Betty, what was the layer of the bottom? How many?
6.
6 times 3 layers, right? Like that?
Yes.
Right. Now, you know the formula that you would have been taught was, oh, length times width times height. Well, that still gets you 18, right? But remember, this is the key part I want to hone in on here, because where misconceptions happen with kids. It's about getting the area of the base of the solid. And the reason I'm really honing in on this is to set you up so that when we do triangular prisms, when we do octagonal prisms, when we do pentagonal prisms, when we do cones, when we do cylinders, it's all about some kind of base area times some kind of height. And that's why that's important to emphasize the base. And notice it's a capital B. A little b is when you're talking about the base of a triangle when you're doing a 2D area. But when you're talking volume, when you say base, you're talking about big B, meaning the base of the solid. And should they have made a different word? Probably, but I'm not the person who created the convention of this math. But that's why that gets confusing. So remember, a little b is talking about a literal side of some kind of polygon. A big B is talking about the area of the base of a 3D figure. Okay, anybody have a question about that? Anybody? All right, let me move on my phone here to number 2. Okay, let me clear out my stuff. All right, will you look at that prism and will you come up with the volume for that prism? Now, it's no harder than the others. It just has a fraction in it. You just have to do some fractions.
As you guys are working, I'm going to drop out here. I enjoyed this so much.
Thank you for coming.
I've been reminded of a few things that I've forgotten. Thank you, Mr. Parsons.
Well, looky there.
Take care, kiddos.
Thank you.
All right. Thanks for inviting me.
Thank you.
I'll come again. Bye, guys.
Bye.
Hope everybody's well.
You too.
Thank you.
Now, if you weren't sure on this one, here's what it actually is. Okay, Graham, will you tell me what you on your answer? Tell me about how to express it.
Was it correct?
So,
Oh wait, it needs 3.
yeah, Madeline, will you tell me how to express your measurement there? Angela, will you give me the measurement with it, please?
Mr. V, I can answer.
Okay, Josiah, Graham, will you walk me through, if you can see on my screen, I've got it started. Will you walk us through that, please?
Walk you through the problem?
Yeah.
Okay. So as it starts out, we do 7.5 times 4, which is 30, I believe.
It is.
And then you multiply that by 2.5, which would be 75.
Yep.
And then you do 75 inches and then cubed, which is 3 instead of 2.
So
Which is the
right.
yeah.
It would be 75 cubic inches. Yeah.
And if
So
you wanted to show that with the little
that's exactly what I'm going to do.
yeah.
All right. So on here, tell you what, Graham, why don't you do it? Use your annotation and do it.
What do you mean by that?
Okay, I'll start it and you finish it. Okay. So
Okay.
we're looking at, there's 2.5 rows of this, right?
Yes.
Okay. So I'm going to put 1 here. There's a row.
Yeah.
Here's a row, right? Or layer.
Yeah.
And
That's correct.
this one is different because it's got a
Half layer,
half
correct?
layer right here. So let me write that. It has a half layer in it, right?
Yep.
Okay. So on the bottom row, there are 30 cubes. Does everybody agree there are 30 cubes on the bottom row?
Yes.
Okay. So I'm going to top that in right here. Right here. 30 cubes on bottom layer. Right? Because 7.5 times 4 is 30 cubes. And I know that because it's 7.5 times the 4 over here. Okay? Does everybody see where he got the 30 from?
Yeah.
All right. Okay. On the next row up, there is another 30 cubes. But on this half layer, how many cubes are there?
15.
Right. So up here, I'm going to write 15 cubes. And they go right here on the half layer.
Mm-hmm.
30 and 30 and 15 is your 75. Okay? All right, let's try another one. So on this one, you've got an easier one because the numbers are easier, right? So would somebody, I'll let everybody answer it, and then would somebody volunteer to walk us through the answer when everyone's finished? Do I have a volunteer?
I'll go.
Who said that?
Pramita.
Okay, Pramita, thank you. So let everybody answer first. Hey, Melis, yeah, you're putting it in. Okay, Pramita, you go ahead and walk us through it. Most people are saying that the same answer. Tell us what you got. Do you have your annotation tool if you want to use it?
Sure.
You don't have to.
Okay, then I'm just gonna do it without.
Okay.
So what I did was I did the base. So I did 10 times 3, which is 30 cubic inches. I mean, no, that's just 30 inches squared. And then I did
Hey,
4, which is
Pramita,
100.
I'm gonna stop you in a second. You were right to say that's 30 cubes because it's literally the bottom layer.
Okay,
You can call it that.
okay then. And
Yeah.
then I did 30 times 4, which is 120. So I got 120 cubic inches.
Yeah. Real quickly, here's the annotation of that. So here's a layer. Here's a layer.
Oh God.
Here's a layer. And there's a layer. Pretend like that's 4 layers tall. And every layer has 30 in it, right? There's 30.
Oh, come on.
30.
Yes, Dad, yes.
30 more. 30 more, right? So you have that the volume is 1 cubic inches.
You're gonna scream.
All right. Let me check and see if everybody is agreeing here. Hey, stop, please. All right. I think everybody got it. All right. All right. Gonna try 1 or 2 more here before we run out of time.
It was 1,200.
Go ahead and try this one, please. What you get?
Hello? Hello?
What the heck is that?
That's a cube.
Eli, they're, I mean, Gray, they're someone else. I know, but
You guys that haven't answered, please go ahead and try it, please. Those of you haven't answered. have a volunteer that will tell me how you get the answer?
I can.
Hey, Mason, is that your little brother and your dog?
Yeah.
Tell him I said hi. Who volunteered? Somebody volunteered.
Me.
Okay, who's me? Betty?
Yes.
Okay, Betty, tell us what you did.
So what I did first, I did 6 3/4 times 4 1/2. Well, no, I did 3 times 2 1/4,
Which is
which equals 6 3/4.
6 3/4.
Yes.
All right.
I multiplied that times 4 1/2, and I
Why?
got 33/8.
Why did you do that?
Well, because like the bottom layer, the base,
Yeah.
would also be multiplied times 4 1/2 because it appears 4 1/2 times in the square.
Right. Yep, that's right. And then you get cubic meters, right?
Yes.
All right. And did everybody agree with that? Yep. I'm looking to see. Yep. All right. Yep. Okay. So that's correct. So bottom layer, there are 6 3/4 square meters. I mean, cubic meters. Then there's another row of that, another row of that, another row of that, and then there's a half row at the very top. And here's why the formula is helpful, because it's hard to draw half rows and half boxes and half cubes and all that stuff. So that's why it's so helpful to understand how to use the formula and why it works. So then you can just plug in the numbers instead of literally drawing all the boxes, right? Okay, we got time for one more. All right, so last one. If you will pick, I'm going to divide you up. So if you'll wait for me, I'll tell you which one to do. So you should see 3 of them on the screen, okay? So I'm going to go down the list, okay? James, Mason, Jayla, and the person who has the purple background. Who is that?
Becky.
Okay, and Izzy, do number 1, you guys. Okay, Jayla, Pramita, Kylie, Melis, Josiah, do number 2. Graham, Lincoln, Michaela, Angelo, Madeline, and Liam, if you'll do number 3. And if I left you out, I'll also do number 3. I think Nathaniel may be there. Nathaniel, also do number 3, please.
Can't see it. Oh,
Becky.
Mr. P,
Yes.
the
Yeah.
connection is like really glitching, like badly.
Which part, the
Hopefully-
Pear Deck or the Zoom?
The Zoom.
All right. If you can still see the Pear Deck, at least go ahead and, did I give you number 3?
No, number 1.
Okay, number 1. You can see it, right?
Yeah.
Okay, waiting on Nathaniel, Liam, and Mason. So on number 1, it's interesting that they put the 3-foot part up there, but that's part of the base, right? All right. So for number 1, you would have multiplied 6 times 3, which is 18, and then 18 times 8. And somebody who did number 1, what's 18 times 8? Somebody who did number 1. 18 times 8.
144.
Thank you. 144 cubic feet. Okay, that is correct. All right. If you did number 2, you would say 2 times 10, which is 20, and then 20 times 5. So if you did number 2, the volume is,
100.
100.
thank you,
100.
100 cubic cm. All right. And if you did number 3, what's the base part? Is it 7 times 4 or is it 15 times 7?
I'd say
15 times 7.
15 times 7. And 15 times 7 is 75?
It's
It's
No.
1.
105
105, yeah. And 105 times 4
is
is
420.
yeah,
Yeah.
420 cubic inches,
Inches.
right?
Yes.
Yes.
All right. So any questions about those? Everybody good on those?
Yes.
All right. So that's
Yeah.
our last one on that. I'm going to quickly introduce where we're going to go next. And that is talking about volume of these prisms. Okay. So on your screen, here's what I would like for you to do. Let me move this. Okay, you're going to draw on the slide. Okay. And what I would ask you to draw is what's missing there. Okay. Something's missing about the volume. So if you can draw on the slide and fix the problem, it's not complete. How would I get the volume of that container? So draw on your screen and tell me, what would I do to get the actual volume of that? We're now moving into volumes of other things besides rectangular prisms. Kyla, I like what you said there. That's interesting. Kayla. So we can't get the answer to this. Is that correct?
Yes.
Yeah, we can't because it's missing pieces, okay? So what we do know right now is at the bottom, all right? We know that the area of the base, let me undo that. Okay, we know that the area of the base down here, they gave us, correct? So the area of the base would be 8 times 9. Area of base, which should be a capital B, would be 8 times 9 or half of that. To be half of 8 times 9. Which would be 36, correct? Why can we not get the rest of the answer?
There's no width.
There's
Okay,
no width or depth.
the height is missing.
All right.
So we can't finish it because we don't know its height. Okay, so what I need right now is to add a height. Okay, so if I tell you now that the height is 10, can we get the answer now? Yes. All right, so the height is now 10. So on your drawing, will you tell me now what is the actual area of this triangular prism? 10, and the area of the base is 36. And remember, I'm using a capital B there because that's the